Alright, so this video will be a practical introduction into Flink. We'll learn things how to easily test Flink applications without actually requiring a Flink cluster and submitting jobs there. One of the reasons I'm recording this video is I've recently started working with Flink more, and I realized there is not much guides like that. So some talks are great, but they are about Flink internals, for example. That's really useful, but from a different level. As a developer, you really want something to quickly experiment with, at least for me. And the other types of video are more like Flink sales pitches about the things we can achieve with Flink. Again, really interesting, not so useful for developers trying to getting started. So the goal of today is to create a payments volume job. So as an input, we'll have a stream of payment events, and as the output, we want aggregates on top of those payments. We want to group payments by custom ID. We want to calculate total amount of payments in that particular window, and we'll be using fixed sized windows of 10 minutes. So the output will be result like custom ID had this amount of payments, number and total amount, and that will be our window and start timestamps. If you want to create a template like this, I just used a Maven archetype that's called Flink Quick Start Java, and that worked pretty well for me. But also all that code I published on my GitHub, so you can just clone that and it should work if you have Maven and Java installed on your machine. Also, I'm still using 1.2 version of Flink. I know there was a big release recently for the Flink 2.x. The issue is that if you're not self-hosting Flink, most of the providers that do the managed Flink version, like AWS Flink or Verica, stuff like that, they are still running the 1.2 version most of the time, and it feels like we just need more time when Flink 2.x will be properly tested and will be available as a managed solution. So it's easier to stick with that particular version, so you don't have much issues when you actually need to deploy your application somewhere. And also, I'm particularly looking into deploying things into Flink from AWS, and I think the version of Java they support is 11, unfortunately. So I pinned that Java version in my project to be 11 as well. So we cannot use cool new shiny Java features from more recent versions, unfortunately. But yeah, the API is not hard, and even this Java version will work really, really well. So regarding testing, as I said, the goal is to have the test locally, and there are different ways how you can test your Flink applications. It could be some unit tests for your process functions, etc. You can also use some available test harnesses from Flink. It's more about like unit test level. In my case, I was interested to run a test as much end-to-end as possible. So I'm going to use the mini cluster with client resource from Flink test utils, and that will basically allow us to run to have like a GUnit rule, and I can show it in a sec like this. So that's our payments volume test job test, and then with the class rule we create the mini cluster with resources, and we can use that as in-memory Flink cluster runtime where we can submit our workflow and execute it. So the thing that how basically the Flink code looks like in a nutshell. It's actually pretty simple. You have like your jar, and then you have a class with a main method, right? And then you just specify that entry point for your Flink, and that main method will be executed when the job will be submitted to Flink cluster. And here we're using this stream execution context env, and at the end, after we define the whole workflow of our Flink application, we just execute it with a name and basically for the visibility in the UI. So Flink is not a database, it's a stream processing framework. So you shouldn't look at that as, like a new place where you can query your data. The goal is to have some kind of data sources, and then the output of the stream processing will be a sink, right? So source is where Flink will get the data, and sink is where the results that we calculated or processed will be published to. And the power of Flink is that sources and all the connectors that we have, it's like a huge range of options that we have. You can imagine like all the JDBC, like relational databases, obviously Kafka, and things like BigQuery, and Kinesis, and more sources and sinks. So it's basically about making your data available to Flink by plugging in a source and then making allowing Flink to know how to publish the data with a sink. In my case, Kafka will be both the source and the sink. So Kafka source, we define Kafka source, we specify the bootstrap service topics that we reading, the group name, and then some initialization, and this is for SSL configuration, and same for the sink, like this. But in that will be only useful when we actually deploy the application. So in that case, Flink job will connect to our Kafka cluster, and then it will read the topic, do the processing, and write to the output topic. And as I said, if you don't use Kafka, you can connect your Flink to database straight with a thing called Flink CDC, and it will just listen to CDC events from your table, for example. And then as the sink, you can still use, let's say, JDBC connector that will update some or upsert some tables in the sink database. So how we now structure tests that we can use the same workflow that we defined in our main function. The idea here is to have the source that we define pluggable, right? So we don't want to put whole code right here. We define source and we define sink, but actually this build workflow function, that's what we will use for the tests. And now let's jump back to the test and we can see how it looks here. So to define our input for the test, we're going to use this from data function, and as an input, it just basically takes a collection of strings. And in our case, our workflow is expecting the stream of strings, which will be our Kafka messages. So after that, we can define the timestamps. We can get to that in a sec. But at the end, when we calling our build workflow, we have our results stream. And here we actually calling toSync with our test helper. And this collect sync is something that we use here, and it's implementing an interface sync from Flink. And inside that class, we have like a collection, like a synchronized list basically of the values. And the idea is that this is plugged now into our stream, and all the events that coming through the stream will be registered in our collect sync. So once our test is finished, we can just get the values from our collect sync, and it will be our actual result, and we can just compare it to the list of things that we expect. And here I'm using the test helper to actually match the collection that will be okay in any order. And that's why, that's because I've set this parallelization to 2, and it's actually recommended by Flink to not use parallelism of 1 in your test, just to catch those edge cases when your job is parallelized on a real cluster and you don't catch those issues in your tests. And in this particular case, as there are 2 windows per customer, they could be executed in parallel. So the order of the window results that published are not really deterministic, because it could be sometimes for the customer A first and then sometimes for the customer B. So that's why we need to use this in any order test helper. So then let's take a look into our input. So we have like a list of payments here. That's like the first argument is the payment ID. Second argument is the amount. Then we have customer ID, which is customer A or customer B. Then the payment status, and then the timestamp of that event. And we all start from this timestamp, and then we just use plus minutes to generate like a sequence of valid timestamps, so we actually can know which events should belong to which window. And here in our stream processing, as we'll see in a sec, we define a window of size 10 minutes, and we'll be using the fixed size window. So it basically will start from starting each 10 minutes in an hour. So the first window will start at 0, then the second window will start at 10 minutes, 20 minutes, 30 minutes, etc., and so on. So in this case, let's see. So customer A will have 5 events. 4 of them, these first 4 rows, will be in the first window, but actually, if you notice, one of the payments will be in pending status, and we'll do the filtering in our stream processing to only include the settled events. So it will be 3 events, 3 payments in the first window, and 1 payment in the second window. This is plus 11 minutes, so it will be in next window. For the customer B, we'll have 4 events in total. 3 of them will be in the first window, and the last one will be in the second window. Right, so let's take a look what we, and to generate a valid data stream, we need to specify the timestamps, and one way of doing that is to assign, to use this with timestamp assigner. In this function, we'll have access to our event, so we can use our event timestamp and extract it and set it to milliseconds. So in that case, our stream will actually include valid timestamps, so our windows will work properly. Let's take a look into the expected list. So you can calculate counts, but I'm pretty sure they are correct. So that's our first window for customer A, first window for customer B. As we've seen, count is 3 here and 3 here. And you can see that window starts, as I said, starts at 0 and then ends at 10 minutes. and the next window starts at 10 minutes and ends at 20 minutes. And again, counts here just one for the second windows for each customer B and customer A. And yeah, finally, let's jump into the our build workflow. It's right here. So we using the data stream of strings as the source. Then we just decoding our JSON strings as we get them into Java classes of payments. After that, that's the first step. And also this name is so we can have that step visible in UI with a particular name. It's quite useful. Second step of our processing is to filter out events with a not correct status. So we're only interested into settled payments. We've done the filtering. We are moving now into aggregations. So we're creating the we first of all doing the keying. We do the key by extracting the custom ID. So now we have separate stream of events for each custom ID. And then we're creating the window, this tumbling event time windows of duration 10 minutes. And this event time basically mean the time that was actually in the payload of the event that we receive. The other option how you can do the processing is the processing time, but that's different beast. It's basically when the cluster got the event, and that will be the time that's used for the windowing. And here we do the aggregate. For the aggregate, you need an aggregator and the payment window function. So here, aggregator will implement the aggregate function. We want a payment accumulator, but yeah, it's a bit like it's kind of a lot of Java here. You need to implement interfaces, stuff like that. But actually, if you look at that doesn't seem really complex, right? You can pretty much understand what's going on, right? So the idea of an accumulator is kind of like if you're coming from functional languages like a reduce, and then you have a stream of things, and then you have the accumulator. The accumulator will know how to apply, how to change state of it based on the new events coming in. And then let's say here, for example, we have the add value. The new thing that we receiving is the new payment. Payment value probably should be named payment here. And then we have the accumulator, right? And we know that we're keeping the same custom ID, and for the total amount, we getting the total amount from accumulator, and we're getting the adding the amount from the payment, and we're just increasing the count in the accumulator. So it shouldn't be too hard to understand, right? And yeah, in this process function, we're using our accumulator, and then when we do the collection, we're creating a new payment window with all of that information, like the custom ID, total amount, count, and we can get the window start and window end from the context window. So once we've done that step, and the windows are closed, we now have this window data stream of payment windows, and the only thing that left is actually to format it back into strings with JSON object mapper, write value as string, and after that we are exiting the build workflow. So in our job, we will attach the Kafka sync, so all the results that we got in that output stream will be produced into a Kafka topic. In our tests, we are not using real Kafka, but we are attaching that test collect sync that we can later use for our test assertions, right? And yeah, that's it. I guess we can demonstrate that it works by running Maven test. And as you can see, no failures and 2 test runs. So yeah, that was the quick introduction into writing Flink jobs with Java API. As I said, this repo is in my GitHub account. A link is in the description. And over time, I'm planning to add more examples here, not just this one. I'm planning to do the sync function, something else like looking into how we use the state stores, etc. So there are a lot of use cases of Flink, and there are also a lot of different APIs available, like Table API, DataStream API, etc. So there's quite a lot to learn. Hopefully that video was useful. Let me know what you think, and if you used Flink before, stuff like that. I'm really interested in your experiences. Please leave likes and comments. That really helps the channel. All right, that's it. Hope you enjoyed the video. See you next one. Bye-bye.